a couple of minutes, we can go through the chapter number 10.3. 10.3. Okay. Okay. 10.3 in inference of regression and correlation. How do you really say you have a correlation? Can you test to see if there really a correlation? Of course, the answer is yes. The hypothesis test of correlation is as following. Like this one, I will skip this one, and the t-score is like this, And to be honest, to calculate this, it will kill you. I think it will kill you. Okay. And here is a little different. The degree of freedom is n-2. It's a little bit different. And the p-value, okay. So I think this part is okay. I will skip this one. And here, example 10.3.1. Testing the claim of a linear correlation. Actually, when I was a master student, we always use this one. And the t-value is about 5.9. Degree of freedom 7. P-value is pretty small. Then we can say that the conclusion, we will reject the non-hypothesis since the p-value is very small, less than 0.5. Interpretation, there is enough evidence to say that there is a positive correlation between alcohol content and the number of calories in 12 ounces of a bottle of beer. But actually, when I was a student, we did a calculation, including for example, I want to measure an unknown chemical about the concentration. Then I use the similar chemical or the same chemical. I do the regression line. Then we use the regression line. I got the formula y equals ax plus b. Then I got the measurement from the unknown sample. I got a value from the machine, from the instrument. I use the value and get the y value or the x value. Then I can calculate the unknown concentration. Is it okay for you? Okay, let me have. At least in my field, the microorganism is very useful. For example, if I have a chemical, and I prepare the chemical in different concentration, for example, concentration 10, 20, 30, 40, and 50, the units, I prepare that. Then I test different samples by an instrument. Then I got different reading. For example, I know the concentration of 10. Maybe the unit is millimolar. Then I got a response from the machine like this one. I got a second response. I got a third response. I got fourth and fifth. Generally, it looks very linear. Then I create a line, the trend line right here. Then I got the formula y equals ax plus b, where the a is the slope of the line. And what's your purpose? For you, your background is business. You want to predict the marketing, the stock market. You want to predict the development of something, and you want to create the benefit from companies, something like this. And for our scientists, if I have an unknown sample, I don't know some compound inside, some concentration, but I use, let me repeat it again. I prepare the 10 millimole of the chemical. I got a reading from the machine, from the instrument. I prepare 20. The reading is like this. I have 30, the concentration, and I got the reading from here. I have the number 4. I got reading here. I have the 50 millimolar, the compound concentration like that. Then I have the machine reading like this one. What's the purpose? After 1, 2, 3, 4, 5 spots, I got a formula. Y equals AX plus B. My purpose is very easy. If I have a sample from a beaker, I don't know the concentration of compound, then I drop the sample into the machine, then I got a signal here. Here, now we can reverse the process. In the past, we used 10, 20, 30, 40, 50. We got different signals. And those signals, the strength of the signals in the instrument are linear. And we get that maybe this time R square value could be 0.9 or 0.98. Very great. That's very, value is very high, close to 1. And I got an unknown sample. The value is here. I can use it to reverse, to calculate the concentration could be here. Is it okay? That's the purpose. Yep, go ahead.
Sir, so the pink line would be the 0.284, the p-value?
The p-value? No. P-value is a different story here. The p-value is talking about, do you think the linear relationship is really correlation? Do you believe it or not? According to the calculation, it's very reliable. And my topic here is I explain why we need to learn the linear regression. What's the purpose? I use my research when I was a master student. We always do this. We have some chemicals with a prepared known concentration 10, 20, 30, 40, 50. I got a response from the machine. And later, I want to measure an unknown sample with the same compound, but I don't know the concentration. I use the machine, the instrument, to measure the concentration. I got the reading like this one. Then I can reverse the process. Reverse it, calculate, could be maybe 23 or maybe 23.2. How can I get it? Because I have the reading. That is a Y. Then I already have A and B coefficient. Then I can get X could be 23.2. Assume the value like this one. And in the future, when you do the prediction in the market, very similar. You can have the linear model, then you predict maybe the economic growth or some the bank or the rates maybe increase or decrease. You can use different model, but linear regression is the simplest one. So is that okay? Let's move. Okay, prediction intervals, and use the regression equation. You can predict the number of calories from alcohol content. However, you only find one value, and the problem is that beers vary a bit in calories, even they had the same alcohol content. Why? Because the alcohol content is not the only factor contributing the calories. It would be nice have a range instead of the single value, similar as the estimate interval, estimate range we learned previously. The range is called the prediction interval. To find this, you need to figure out how much error is in the estimate from regression equation. This is known the standard error for the estimate. Okay, here standard error for the estimate, very similar to the standard deviation. Okay, this is the sum of squares of the residuals. And I will not ask you to memorize the formula because we are open book exam, so you don't worry about that. And this formula is hard to work with, so there is an easier formula. You can also find a value from technology such as calculator. SE equals square root of SSY minus B times SSXY divided by n minus 2. And sure, we can use the free web applications. We don't need to memorize it. Okay, let me accelerate here. Okay, I will skip this one. I will skip this one. Okay. Okay. Example 10.3.4. Doing a correlation and regression analysis using the technology. Sure. This one uses the R, but for myself, R is advanced technology. We can use the Google Office and use some free applications. I think it's easier for us. Like this one. Okay. And scatter plot VS elevation. We did a similar question previously. Okay, we can check the results. Conclusion: reject a non-hypothesis since p-value is very small. And interpretation: there is enough evidence to show that a negative correlation between elevation and the high temperature. Again, what's the purpose? Because different cities and different altitudes in feet, and generally the trend is from left up to going right down, and the trend I think is very significant, and it's a correlation that the city located on a high altitude, the temperature will be lower. And how to calculate that? You can use the formula here and get the results. Okay. I think we finished this part. Okay, and the following is homework. Okay. Close to the break time. So, any question? No more question. I think next week we will come back this one. I will give different foods. And next time I will let you in advance. Okay, I hope you can enjoy the food testing today. And see you next week. What's your question?